Hello guys, welcome back to my YouTube channel. I am Akshata Patil from Sri Venkateswara College of Engineering, Bengaluru, and the today's subject is chemistry and the topic is corrosion and its types. In this video, we will discuss following points. First one is what is the corrosion. Second one is types of a corrosion. In that type of a corrosion, first one we will discuss differential metal corrosion. Second one differential aeration corrosion. In differential aeration corrosion, we will discuss waterline corrosion and pitting corrosion. So let's start with corrosion. First of all, we will discuss what is corrosion. The destruction or deterioration or loss of metals or alloys by the surrounding environment through chemical or electrochemical reactions. It is called as a corrosion. The example for corrosion is rusting of iron, a reddish brown scale formation on iron object. Corrosion may occur either in a dry environment or in an aqueous medium. So here we will discuss what is the dry corrosion and what is the wet corrosion. Dry corrosion is also called as a chemical corrosion. Dry corrosion involves the direct attack of a metals by dry gases, mainly through chemical reaction. Example of a dry corrosion is the attack of a dry air or oxygen on a metal to form an oxide layer over the surface. Then the second one is the wet corrosion. Wet corrosion is also called as the electrochemical corrosion. Wet corrosion involves reaction in aqueous solution medium. The conducting surface of the metal undergoes an electrochemical reaction with the moisture and oxygen present in the atmosphere. Example of a wet corrosion is rusting of a iron. Next we will see one video of a rusting.
If an iron object is left out in the rain, a reddish-brown layer is deposited on its surface after a few days. This layer is called rust. Iron reacts with oxygen of the air in the presence of moisture to form a substance called iron oxide, which we call rust. This is a chemical change because this change is permanent. You cannot get back the iron from iron oxide. The chemical equation for this reaction can be represented as iron plus oxygen plus water, iron oxide.
So next we are going to discuss the types of a corrosion. First one is the differential metal corrosion and the second one is the differential aeration corrosion. So first we will discuss differential metal corrosion. Differential metal corrosion occurs when two dissimilar metals are in contact with each another and exposed to a corrosive conducting medium. The metal with a lower electrode potential acts as anode, undergoes oxidation and gets corroded, and the other metal with higher electrode potential acts as a cathode, undergo reduction and protected from corrosion. This type of a corrosion is called as a differential metal corrosion. It is also called as a galvanic corrosion. The rate of a corrosion mainly depends on difference in a potential between two metals. As the higher the difference in a potential, then the rate of a corrosion will be high. So example for the differential metal corrosion is when iron is contact with the copper, the iron becomes anodic and undergo corrosion, whereas copper becomes cathodic and remains unaffected. Then the second type of a corrosion is differential aeration corrosion. When a metal is exposed to a different concentration of air or oxygen, the part of a metal exposed to a lower concentration of oxygen becomes anodic and undergoes corrosion, whereas the other part of the metal exposed to a higher concentration of oxygen becomes cathodic and remains unaffected. This kind of a corrosion is called as a differential aeration corrosion. Example for differential aeration corrosion is iron rod partially immersed in a NaCl solution. The part of a metal immersed in a solution undergoes corrosion, whereas a part of a metal outside the initial solution remains unaffected. The typical examples of a differential aeration corrosion are the waterline corrosion and pitting corrosion. First, we will discuss waterline corrosion. It is observed in a steel or iron water tanks partially filled with the water. When a steel tank is partially filled with the water for a long time, the inner portion of the tank below the waterline is exposed only to the dissolved oxygen, and the portion above the waterline is exposed to more oxygen. Thus, the portion below the waterline acts as anode and undergoes corrosion, and the upper portion acts as a cathode and is unaffected. The distinct brown line is formed below the water tank because of a deposition of a rust. So the cell reaction for the waterline corrosion at anode and cathode. At anode, M raised to Mn plus N electrons, and at cathode 2H2O plus O2 plus 4 electron raised to 4OH minus. Finally, the ions combine to form corrosion product. Example for the waterline corrosion is ships which remain partially immersed in a sea water for a long time undergo waterline corrosion. Next, the second example for the differential aeration corrosion is the pitting corrosion. This type of a corrosion is observed when dust particles or oil drops deposited over the metal surface. Pitting corrosion results when the portion of the metal covered by dust which is less aerated becomes anodic and undergoes corrosion and form pit. The remaining area of the metal which is exposed to a higher concentration of oxygen becomes cathodic and remains unaffected. Pitting corrosion is occurs due to the following reason. First one is the metal surface is not a homogeneous, and the external environment is not homogeneous, and the crystallography directions are not equal in the reactivity, and the environments are not uniform with respect to the concentration. In pitting corrosion, if once a small pit is formed, the rate of a corrosion increases because of the formation of a small anodic area to corrode faster because accepting electrons from the cathodic area increases. Then the cell reaction for the pitting corrosion at anode and at cathode is at anode Fe raised to Fe2 plus 2 electron, and at cathode half O2 plus H2O plus 2 electron raised to 2 OH minus, and the net reaction will be Fe2 plus 2 OH minus raised to FeOH twice. Thank you guys for watching my video. Please like, share and subscribe.